Hello students, welcome to EPG Pathshala. I am Dr. Dinesh Kalyanasundaram from Indian Institute of Technology, New Delhi. Today we are going to discuss about a module on integral calculus. The objective is to understand what is integral calculus and the importance of integral calculus. Then again our style of finishing up with various applications. Contents. First we are going to see the specific contents. We want to see what is the base understanding for integral calculus. Then we are going to see what is area under the curve, what is the definition of integral, then the definite and indefinite integrals, integral theorem, property of integral, and integral of some common functions, and finish up with some applications. So the basic introduction. Now where does integral come from? First we have to understand the twin brother of integral. The different derivatives are the complementary functions or cousin brothers of integral functions. Here by some practical example we will have to approach the concept of definite integral. Now you are seeing, you imagine you have a rectangle of area A and the height was h and the w width w. From geometry we know that the rectangular area A is a product of h times w. Estimating area. Let us say we want to find the area under the curve. Given in the graph, y is equal to 1 minus x squared, and it is between the points 0 to 1 on the x axis. So a is equal to 0 and b is equal to 1 for this case. The first thing is, if we need to know the closed interval, which means it includes 1 as well as 0, is 0 comma 1 square brackets. We can't find this area by just simple formula. Here what we can do, what we are doing is a approximation. We are using squares of h height and delta x width to find the area. So we are using a lot of squares to find the area and subtract the blue region. And you can actually see, if we add the two squares or the rectangles, that area is going to be more than the area of the curve. By that blue region, it will exceed. We can actually improve the solution. That means we can improve the accuracy of the solution by putting in several rectangles, not one but very many rectangles. Then the size of the blue area is diminishing, so we are going to a better approximation. Here you can see we have put much more rectangles, so the error is decreasing. As the width of the rectangles is decreasing, error is also decreasing. Estimating area. So we can represent the sum of all the rectangles as h times delta x plus h times delta h2 times delta x plus h3 times delta x and up to hn times delta x, which is also equal to, the height is actually the function value of the function at the point x1. So we can replace h1 as f of x1 and h2 as f of x2, and similarly hn as f of xn. Okay, this is the right hand sum. Similar estimation can be done by underestimating the area. The underestimating the area will be h naught delta x, h1 delta x, then h2 delta x up to h of n minus 1 times delta x. So that is going to be f of x naught times delta x, then it goes similarly up to f of x n minus 1 delta x. Definite integral. In both the cases, as we reduce the width del x, there will be more number of points between the endpoints a and b, and the amount of error in area reduces. Also, when del x is very small, area calculated from underestimating or overestimating will come to a common value. This limiting value, when n tends to infinity or del x tends to 0, is called definite integral. Mathematically, the integral extending from limits a to b f of x dx can be written as limit n tends to infinity, and you change the value of I from 1 to n f of x I d del x, right? Then it becomes limit n tends to infinity f of x into del x, f of x2 into del x, f of x3 into del x, up to f of xn into del x. That can also be written from I is equal to 0, then it becomes f of x0 to f of x n minus 1 del x. Going to slide number 16, solid of revolution. Imagine we take a rectangle as shown in the figure. Then if we rotate the rectangle over the x-axis, then we are going to form a cylinder. These things can be done and by using integrals. Okay. So why are you using that estimating volume? Definite integral. Definite integral is calculated by the formula shown in the screen. It has a S-shaped symbol, that is meaning the integral symbol, that is a sign. Then you see small a and small b, then it says the lower limit of integration. So remember that it is a closed interval, meaning the point a will also be considered during integration. It extends, so you are going to integrate or accumulate from point A going up to point B. And what are you going to integrate? That depends on the function. The function is denoted by f of x. The x here is called the integrand. So function is the integrand and x is the variable of integration. This complete term is the integral of the function between a to b, from a to b. Points to remember. The procedure of calculating an integral is called integration. The definite integral a to b integral sign f of x dx is a number and it does not depend on x. We put any variable in place of x. So that x means arbitrary variable. Arbitrary meaning it can be any variable. So a to b integral f of x dx is the same as a to b f of u du, the same as a to b f of t dt, as f of r dr and f of theta d theta. Solid of revolution. About the coordinate axis, if you take a semicircle and rotate it as shown in the figure, you will end up with a sphere type of an object. So that is what we are seeing on the right side of the picture. Let us say we have a very complex cone as seen in the figure and we want to estimate the volume of the cone. We can't find this volume V by simple formula. We can estimate V by dividing the cone into smaller pieces, and each small piece is a thin cylindrical disc of width or thickness del x, and the radius is the instantaneous value of the function f of xi. Estimating volume. Volume of revolution. A solid of revolution is formed when a region bounded by the part of a curve is rotated about a straight line. Consider the function f of x on the interval a and a comma b, that is the closed interval. Now consider revolving the segment of a curve about the x-axis. So we basically revolve it about a particular axis. This volume of solid generated by above revolution of a curve, so assuming this is the curve, it can be a straight line, it can be a curved line, can be estimated through definite integral. Find the volume of an uneven cone. Volume of a small cylindrical disc is equal to del V is equal to pi into radius squared into height, which is pi into f of xi squared into del x, where f of xi is the value of the function or the radius for the disc. So the total volume is going to be pi f of xi squared into del x integrated or summation from I is equal to 1 to n. When we apply limit n tends to infinity for the above sum, it actually gives the actual volume of the cone. So when you apply pi limit n tends to infinity, I is equal to 1 to n f of xi whole squared into del x, then you can just write the same equation that we got earlier. Then we will see that volume V is equal to pi into integral a to b f of x squared dx, where a and b are the two endpoints in our example. Volume of revolution. Rotation about x-axis, y is equal to f of x. Therefore, volume is equal to pi into a to b f of x squared dx. Rotation about y-axis. The volume here is going to be replaced between a to b x squared dy, and that is f of y whole squared dy. Volume of a lake. Suppose we want to find the volume of a big lake as shown in the figure. Again, we consider this volume is formed by revolution of an arbitrary function which defines the bottom of the lake around the y-axis being the depth and the two endpoints. For defining bottom of an arbitrary function lake, it could be any polynomial f of y, which can be defined as y power 4 plus 3 y squared minus y. The two endpoints are a is equal to 0 and b is equal to h, which is the depth of the lake or the height of the lake. Then we can find the integral of the lake by definite integral pi going from 0 to h f of y whole squared dy. So definite integral can be used to determine either area of a regular or any irregular shape, or it can be used to find the volume of a regular or irregular shape. Properties of definite integral. Order of integration. If we change the order of integration, then it gives out a minus sign. So a to b, if the limits are interchanged, so then b to a, then there is a minus sign. Then there is a zero width interval. That means if you integrate from a to a itself, then it's a zero width. Constant multiple. If there is a constant which is getting multiplied, then you can take the constant outside and then integrate it. Sum and difference. So if there are two functions f of x and g of x, whether it is subtracted or added and it is integrated within the same limits, then you can separately integrate them with the same operator, plus or minus. Additivity. If the limits are overlapping for the same function f of x, that is a to b and b to c, then you can directly do from a to c. Fundamental theorem of calculus. It establishes a connection between two branches of calculus, differential calculus and integral calculus. Fundamental theorem of calculus, part 1. If f is a continuous on closed intervals a and b, then the function g is defined by the equation g of x is equal to a to x f of t dt, and x lying between a to b is continuous on a comma b and differentiable on the open interval a comma b, that means not on the points a and b, and g dash of x is equal to f of x. Fundamental theorem of calculus part 2. If f of x is continuous on a comma b, then f of x integrating between f of a to b within the limits a to b, you can write it as f of b minus f of a, where f is any antiderivative of f, the capital F is an antiderivative of small f, that is a function such that f dash is equal to f. Importance of theorem. It lies in the fact that before discovery of this, it was very difficult to measure the area or length of a curve, volume of irregular shaped objects, but now this integral has helped us to measure all this. Differential and integral calculus are inverse to each other. Now what do we mean by that? So if we rewrite the part 1 of the theorem of the calculus, we write d by dx, we are differentiating the integral a to x f of t dt. It will again give the same function f of x, or you can just say, because we are differentiating with respect to x, so we will end up having f of x, which means that if we integrate the function f and then differentiate, we will end up getting the original function f. Hence the theorem of calculus says that the differentiation and integration are inverse process. Indefinite integral. Fundamental theorem of calculus says that antiderivative of the function f is a to x f of t dt. This antiderivative is known as also indefinite integral and represented as f of x dx is equal to capital F of x. The process to find integral is integration. Note definite integral, indefinite integral, integral f of x dx is equal to f of x is a function where definite integral a to b f of x dx is a number. Integration rule. Sum and difference rules. U plus v dx is integrated over dx is, you can integrate u and v separately, that is integral u of x dx plus integral v of x into dx. The minus is going to be just replace minus v by minus, replace plus v by minus v, then you will get the other one. Then integration by parts. Integral u v dx is equal to integral u integral v dx minus the whole integral of du over dx integral v dx into dx, where v should be the function such that its integration exists, and generally u should be the function such that its successive differentiation converges. Integration by parts. Example: integral x sin x dx is equal to x sin x dx minus integral d by dx of integral sin x dx into dx. So the first one, integral sin x dx, is going to give cos x minus cos x. So the first term is going to be minus x into cos x. The second term inside the square brackets is going to give us minus cos x. Then integrating minus cos x dx is going to be gives us sin x. So totally it is going to be minus cos x plus sin x. Here u is equal to x and v is equal to sin x. Then another example of integral x tan inverse of x dx. That is going to be tan inverse x integral x dx, and here u is equal to tan inverse of x and v we are considering as x. So when you substitute all these things, you should finally get x squared by 2 tan inverse x minus x by 2 plus 1 by 2 into tan inverse x. Substitution rule. Substitution rule is, if u is equal to g of x is a differentiable function whose range is an interval I and f is continuous on I, then integral f of g of x into g dash of x dx is equal to f of u du. Example, integral x into e power x squared dx. Put x squared is equal to u, then 2x dx is equal to du. So integrating e power u, so we have to substitute in terms of u, so then it becomes e power u into du by 2, which is equal to 1 by 2 integral e power u du, and e power u du is equal to 1 by 2 e power u, because if you differentiate e power u, it's always e power u. If you integrate e power u, it's always e power u. So then it is equal to 1 by 2 e power of x squared, because we have to put u as x squared, so we are returning. So these are all indefinite integrals. Then we are going to see another example, integral sin x divided by 1 plus cos squared x into dx. Put cos x is equal to u, then x dx is equal to sin of x into dx is equal to du. Then if you integrate, then if you substitute everything, then it should be integral 1 over 1 plus u squared into du, which is equal to tan inverse u. Then when you substitute u back as cos x, then the solution is tan inverse of cos x. Indefinite integral of some function. Find the integration of y is equal to x squared. We can do this by anti-derivative method. So let us find whose derivative is x squared. D by dx of x cube is equal to 3x squared. So therefore 1 by 3 of d over dx of x cube is x squared. So d by dx of 1 by 3 x cube is equal to x squared. So therefore 1 by 3rd x cube is the antiderivative or integration of x squared, and we can write integral x squared dx is equal to 1 by 3 x cube. Indefinite integral of some functions. So these are for your reference, and you can refer to all these functions. Applications. Change in volume. If V of t is the volume of water in a reservoir at time t, then its derivative V dash of t is the rate at which the water flows into the reservoir at time t. So V dash of t going from t2 to t1, integrating from t1 to t2 dt is equal to V of t2 minus V of t1. It is the amount of change in the water in the reservoir between time t1 and t2. Then calculation of multiplication of cells in a cell culture. If the rate of growth of a cell in a cell culture is dn by dt, then integral t1 to t2 dn by dt into dt is equal to n times t2 minus n times t1 is the total multiplication of cells in the cell culture during the time period n1 minus n2. Change in population. If the rate of growth of a population is dn by dt, then a similar population change similar to cell culture can be done. Then increase in the cost of production. If Cx is the cost of production of x units of a commodity, then the marginal cost is the derivative C dash of x. So integral between x to x2 C dash of x dx is equal to C times x2 minus C times x1, and C being the function here. Is the increase in cost when the production is increased from x1 units to x2. Measurement of mass of a segment of rod. If the mass of a rod measured from left end to a point x is m of x, then the linear density is rho of x is equal to m dash of x. So the integral a to b rho of x dx is equal to m times b minus m times a. where the mass of a segment lies between x is equal to a and x is equal to b. Summary. So definite integral is a very nice tool to measure area bounded by a curve or a segment of a curve. Volume of a solid generated by revolution of a segment of a curve or a curve. Definite integral is a number and does not depend on the variable. Fundamental theorem of calculus relates differential calculus and integral calculus. Indefinite integral is a function, also called antiderivative.